type of domain. This is a collapsed domain. So that happens when you have a cave passage and then the surface collapses into the cave. And it happened here because we have really thin beds. You can sort of see them on the back side of the wall, and they're just not strong enough to hold up this cave roof.
At some point in the cave's past, the river ate away at the cave roof where the limestone beds are thinner. The river damaged the ceiling rock so much that eventually the roof collapsed. This collapse is known as cantilever failure.
You can think about, theoretically at least, having a piece of rock sticking out like a diving board. You can only stick it out so far before it breaks off under its own weight. And that's exactly what happens. As you make the cave bigger and bigger, you're forcing basically a diving board of rock, a slab of rock to stick out and support its own weight.
The limestone beds in this part of Vietnam are especially thick, with very few cracks or weak points. The river tunnels through this landscape, challenging the strength of pure limestone. And the dolines brutally reveal the few places where the rock beds are thinner, weaker, but still divine. Here, open to the sun and the rain, life thrives. Dr. Tai Nguyen and Annette Betcher are the first to climb into the undergrowth. She's eager to tap into Nguyen's expertise in rainforest plant species to figure out how this subterranean wonderland compares with the surface. After disappointments in the first part of the cave, the Doline fulfills Betcher's expectations. Here is an area rich with life, a unique and unexplored ecosystem.
This is absolutely fantastic. It's a treasure trove for biologists. And everything that lives here has got here by complete chance. So birds have dropped seeds, plants have sprouted up.
This species outside is evergreen.
Okay.
Just.
Right.
But here it's fallen down the leaf in the winter, I think so.
Okay, so you think it's evergreen outside, but it's deciduous in here. And so the young leaves are those, the red leaves? Are those young leaves? Okay, right.
Betcher had hoped to find new species of plants, evolved to flourish in this strange underground world. But Nguyen doesn't see examples of unique evolution. Instead, he thinks the plants in the Doline are showing extreme adaptation. It's a process known to biologists as phenotypic plasticity.
In particular in plants, their outer form is very variable. They can adapt themselves very much to their environment. So there could be two plants that are perfectly the same species, have the same DNA, but because they're in a different environment, they actually look quite different. That's the plasticity bit. So I think we're seeing an example of spectacular phenotypic plasticity.
Unique adaptations appear throughout the Doline. In the tropics, trees are usually evergreen due to the absence of seasons. But down here, they're deciduous, with sparse foliage and narrow trunks. Dr. Nguyen theorizes that this is how the trees adapt to the comparative lack of water and shortage of light. These steep Doline walls enclose this mini jungle and act as a natural barrier to the outside world, trapping pockets of life deep within the cave. Betcher looks for soil thick enough to lay some surface traps. Alcohol will preserve any creatures that venture in. Now she must try to find any signs of life in the dark cave. But so far, the chance of finding anything of significance doesn't look good. Could the acidic water that created this cave also be destroying all life within?